Hello, everybody. Now let's begin our first review session. Today, I will go over 4 questions. 3 questions are on the professor's slides, and 1 is from the textbook. So first, let's look at the one from the textbook, which is the question number 2.1. And let's look at the question. Hi. Hello. So we are gonna go over the question 2.1 from the textbook then. So let's see the question first. What percentage of cost of Dell computer reflects inventory cost? So this is the question, and the question is asking us to calculate the inventory cost. Assume Dell's yearly inventory cost is 40%. To account for the cost of capital for financing the inventory, the warehouse space, and the cost of obsolescence. In other words, Dell incurs the cost of $40 for a $100 component that is in the company's inventory for 1 entire year. In 2001, Dell's 10K reports showed that the company had $400 million in inventory and COGS of 26,442 million. Okay, so we are going to calculate the inventory cost of this problem. So how do we calculate the inventory cost? We have the formula from professor. The per unit inventory cost equals annual inventory cost divided by the annual inventory turns. And from the problem, we know that the annual inventory cost is 40%, but we don't know the annual inventory turns. So how to calculate the annual inventory turns? Since we know the inventory, we know the company had 400 million in inventory and COGS of this number. So we can know that we can calculate the annual inventory turns using the formula COGS divided by inventory. And COGS is 26,442 and inventory is 400. So we can get the number. This equals 400. This equals 66.105 turns. This is turns per year. And we plug in the number 40% divided by 66.105. Then this equals 0.605% per year. So this is the per unit inventory cost. Okay. Any question? If you don't have any questions, then let's look at question 2.2. And this is the question from slide 2. Let's look at this one. Consider let me see. Yes. Consider the baggage check-in. Should be our check-in data. Consider the baggage check-in of a small airline. Check-in data indicate that from 9 a.m. to 10 a.m. 255 passengers checked in. Moreover, based on counting the number of passengers waiting in line, airport management found that the average number of passengers waiting for check-in was 35. How long did the average passenger have to wait in line? So for this one, we have two numbers. The first one is 255 passengers checked in, and the second one is in the wait line. The number of waiting passengers is 35. So from here, we know that the 255 can be treated as the flow rate. And the 35 can be treated as inventory. Because in the waiting line, there are 35 passengers. So this can be treated as the inventory. So from these two terms, so we can know that we are gonna use the Little's law. So what is Little's law? It's the
inventory
average inventory
flow rate
equals average flow rate times average flow time. So how long did the average passenger have to wait in line? This is the flow time. So we just need to plug in the numbers then. Then the flow time, which is the average wait time, which is the flow time, equals average inventory, which is 35, divided by the average flow rate, which is 255. And we got the number equals 0.137, and the unit is hour. And this equals 8.24 minutes. Okay, so here we applied Little's law. Let's look at another one. Let's look at question 2.5. I think it's the same. La Villa is a sorry. La Villa is a village in the Italian Alps. Given its enormous popularity among Swiss, German, Austrian, and Italian skiers, all of its beds are always booked in the winter season, and there are, on average, 1,200 skiers in the village. On average, skiers stay in La Villa for 10 days. So the first question, how many new skiers are arriving on average in La Villa every day? So for this one, we can also use the Little's law. And here in this question, in this problem, the 1,200 skiers act as the inventory. Because the resort is always booked and fully booked, and there are 1,200 skiers in the village. So this is the inventory, and on average, skiers will stay in the villa for 10 days, and this can be treated as the flow time. Then we can calculate the flow rate. Which equals the inventory divided by the flow time. So every day there are 120 skiers per day. That are arriving on average in La Villa. And let's see. Hey, can you see question B? Okay, let me share screen. Let me share another screen. Yeah, let's see question 2.5. Question B, a study done by the largest hotel in the village has shown that the skiers spend on average $50 per person on the first day and $30 per person on each additional day in local restaurants. The study also forecasts that due to increased hotel prices, the average length of stay for the new season will be reduced to 5 days because the old one is 10 days. What will be the percentage change in revenues of local restaurants compared to last year? Last year is when skiers still stayed for 10 days. Assume that the hotels continue to be fully booked. Let's return to our previous one. And let me write the numbers. So for the first day, the average cost is $50, and for the rest days, the average cost is $30. So we need to compare the increase, or decrease changes about the average cost of the skiers spent this year and last year. So let's see how to calculate the average amount of money that each skier spent for last year. Let's calculate the average amount of money for 10 days. How do we calculate it? Because the first day, each skier spent $50 plus the rest 9 days when they spent only $30. So for 10 days, each person spent $320. So for this year, because the average stay for this year is only 5 days. So for the first day, they also spent $50, but because the average stay is only 5 days then, so we only have 4 days left times $30 per day. This is a 5 days stay for a skier. However, we are calculating the 10 days cost. So we multiply by 2. Then can find this equals 340. So what will be the changes? We can just use 340 minus 320 divided by the 320. This equals 6.25% increase. Because this is a positive number, so the cost has been increased. Okay, let's look at the last question. Question 2.8. So this is a strategy consulting company that divides consultants into 3 classes: associates, managers, and partners. The firm has been stable in size for the last 20 years, ignoring growth opportunities in the 90s, but also not suffering from a need to downsize in the recession at the beginning of the 21st century. Specifically, there have been and are expected to be 200 associates, 60 managers, and 20 partners. The work environment at the company is rather competitive. After 4 years of working as an associate, a consultant goes either up or out. That is, become a manager or is dismissed from the company. Similarly, after 6 years, a manager either become a partner or is dismissed. The company recruits MBAs as associate consultants. no hires are made at the manager or partner level. A partner stays within the company for another 10 years, a total of 20 years with the company. So let's look at the first question. How many new MBA graduates does the company have to hire every year? So for this question, for this problem, let's look at the whole problem. So let's look at how to analyze it. They have associate and manager, associate, manager, and partner. So they need to spend 4 years to become a manager, and another 6 years to become a partner. For the associate, the number of associate is stable, which is 200, and the number of managers is 60, and the number of partners is 20. After 10 years, the partner goes out and they only recruit the new MBA student. The MBAs. So the first one is asking us, how many new MBA graduates does the company have to hire every year? So based on our previous experience from the previous problems, so we see that the 260 and 20, we can treat them as the inventory. And also we can treat the 4 years, 6 years, and 10 years as the flow time. So how many new MBA graduates? We can treat this one as the flow rate for just the flow rate for this small system. So how to calculate the first question? Flow rate equals inventory divided by the flow time, which is 200 divided by 4, which is 50. So we need to hire 50 MBA graduates. MBAs, okay, per year. So this is the question for, this is the answer for question 1. And let's look at the question 2. What are the odds that a new hire at the company will become a partner? Since we are gonna calculate the ratio that the new hire at the company become a partner, so we need to know that a new hire from associate, the ratio of a new hire from a new hire from associate to manager, and the ratio of a manager becomes the partner. So first, let's look at the ratio of associate become a manager. So let's see question 2. Since we have already calculated the flow rate of the manager, of the associate level, so to become a manager, let's look at how many associates enter the manager position every year. Then this is the flow rate at the manager level. And how do we calculate this? We use the inventory at the manager level, which is 60, divided by the flow time, which is 6, and this equals 10. So for the manager level, every year there are 10 associates enter the manager level. Associate every year. And we also know that for the manager level, its size is stable at 60. And however, to the partner level, there are only 20 who enters the partner level. So I'm sorry, let's see. Yes. Oh, I'm sorry. So since there are only 10 associate promote from the associate to manager. So in the size of each group is stable. So we know that every year there are also 10 managers that can be promoted to the partners level.
No.
And we also know that there are 40 managers that are to be dismissed.
Every year?
So the odds for this level equals 10 divided by 10 plus 40. So this is 0.2. Then let's look at the system for the partners level. We also need to know that the flow rate for the partners level is equals 20 divided by the 10 years, which equals 2. So every year there are only 2 managers enter the partners level. That means every year there are 2 partners left, the 2 old partners left the partners level as well. And also for every year, 8 are dismissed. So 8 are dismissed. Okay, so the odds for this level equals 2 divided by 2 plus 10, which equals 0.2. So if we want to calculate the odds from the odds that a new hire become a partner, so we need to multiply these 2 odds. We use 0.2 times 0.2, which equals 0.04. So this is the odds that can be promoted. Of a new hire to be a partner. Okay, so I think that's all for today's review session. Any question? I think this will help you guys to do the homework. So if you have any question, just email me And that's all for today. Thank you so much. See you.